Good morning, everyone. I'm Enrico Boscaro with CAREL Industries, and today I'm going to talk to you about a new paradigm for HVAC controls connectivity in data centers. It's the concept of embedded edge, and today, as a world premiere, we are talking about a specific product which is using that concept, and it's the Boss One. So thanks, everyone, for connecting. I think that I very much agree with the organization putting together all these topics. Energy efficiency, cost optimization, and DCiM. And partly we will see that today because we believe that the energy saving doesn't come only from a very efficient device, such as the ones we are manufacturing, but indeed from the coordination of all of them. And nowadays, current technologies are really allowing you to pull out more information, more data from the devices, and on the other side, using modern technologies, you can analyze them, artificial intelligence, finding ways to optimize systems. And this, in the end, brings us back to information, data, and connectivity. In the next few slides, I will go back to a little bit of the history of connectivity for HVAC controls. Since the first microprocessors controllers appeared in air conditioning, but I think we can say pretty much the same thing for other type of equipment inside the data center. The microprocessor was allowing communication between controls, and that was used for synergy, backup, redundancy. At the same time, having a microprocessor allowed the creation of a network to share data with a higher level system like a BMS. So indeed, the connectivity wasn't optional. Nearly every controller could be connected throughout an optional card or a gateway using protocols with the different physical layers. So RS485, FTT10, and then Ethernet appeared, and using different protocols. The concept is to replicate the functionality of the display, reading values, writing values, having notifications just remotely. And in the end, there was an evolution of the protocols. So we moved from having a list of numbers and separately, let's say, a key for the interpretation of those data, to higher level protocols with standards that define objects, bringing not only a number, but also other information like unit of measurements, thresholds, and so on. Let's go to current connectivity, because Ethernet was a game changer in the end. The value, by the way, is always on the BMS. With the current connectivity, though, there is a convergence towards Ethernet. Connectivity is not any longer an optional, it's a standard, and this convergence is given by the fact that Ethernet is very popular inside the data center, easy to troubleshoot. You have cables there, you have probably people who can deploy an Ethernet network, but they cannot connect an RS485. At the same time, the multi-client possibility given by the Ethernet, so using different protocols, having different layers, different systems, accessing those data was important as well, together with the services given by the Ethernet, so web browsing, FTP, file transfer, and so forth. The security then starts to be on the device, not on the SCADA system. And this is bringing us towards the next scenario. I'm not saying future connectivity scenario, but it's just the next one, because it's already happening. So as long as Ethernet is used, now it's IT people coming. So the connectivity is a standard, but the Ethernet standards are defined by IT people. And on top of that, the expectation is to go beyond protocols, we are not doing, and we won't be doing BACnet probably in the future. The expectation from IT people is that the system itself, it's presenting, giving with a file, XML, JSON, these kind of things, to present both the data and the meaning of the data. Then security must be on board, and it must be a high level of security. This requires computational resources for encryption, for checking, and so forth. So the expectation more and more in this convergence between IT and OT that is very popular in industrial environment, for example, and we see that in data center we are using more and more standards coming from the industry, is to communicate more with a computer or an edge rather than a simple controller, a simple thermostat as it used to be in the past. That's why we use this edge topology that is very much familiar with IT people. I'm using this image courtesy of Gartner, but it's published on their website, just to explain how, and you can find many of those, the edge concept is now, I'll use a word that is very popular, immersive. Edges are everywhere. That's not only the cloud and the physical endpoint, but here you can see many level of edges in between, ranging from the compute edge to the gateway edge. But in the end, you see in this concept, the device edge. So we are replicating somehow for HVAC controllers the same concept. Where is the edge? And what is the edge? There are many definitions, but in my opinion, we can define this is a very simple one. An edge is something that is creating an endpoint, a connection between two systems. It's an interface that is also providing some value through separation and integration, combining these two things together. It's not a simple gateway. It's not something that is simply dispatching data. An edge is something that is bringing you value. And this is happening. It was happening already in data center using, let's say, something decoupling the communication between a group of units and the system, or a room, or even a plant or a floor of a specific data center. We are bringing this concept to the main controller, to the main unit, to the main cooling unit in this case. And that's new. And today it's a world premiere of this new product. It's called the Boss One. And in the end, it's an embedded edge. What is an embedded edge? What is its value? It's embedded but separated. What we said before, an edge is something that is creating a link, but it's also providing a separation. So it's integrated in the controller. It's not another network. It's not another gateway, but it's specific for that piece of equipment. It's got a separate microprocessor. It's not like having a controller with two Ethernet. We have dedicated resources, adding a layer of security, having the proper computational power to manage, for example, encryption. And then providing redundancy too is very important, because you can really hard code inside the main controller the possibility to survive and provide the cooling service, even if we were under an attack that is destroying the edge or putting that into a critical situation. Other value that an edge can add is the coupling, so remapping, filtering variables, selecting the one you want to show and share, with the flexibility also having virtual variables. So again, an edge is providing you value because you can put together variables, create a virtual variable, add some edge event, which are completely separated from the main controller. For example, a temperature threshold that is different from a temperature alarm. The boss one is providing for sure a value as an edge and as a gate to manage access control with defining profiles and passwords for different users, having a password strength control, a default procedure to change the password, the default password at the first startup. I have to admit that all of those are very familiar to us because they are coming from the standards of IT people. These are the things we are doing for our email system and for any other website we are accessing, any portal whatsoever. And another important part for access control is the log of event. So it's something like a guardian that is able to record the login of users, the changes made with a timestamp to go back and see what happened. Something we will comment later on is the LDAP, centralized management of passwords. Value means also the fact that you can really have some data on it. Recording data allows you to see them, change them, and display them even without going to the BMS. So providing a dedicated access to someone who can see only that specific equipment and not the main DCiM system. So it's another idea to providing access of information to the ones who might be able to do some troubleshooting using those information, but not giving them the complete access to the DCiM system. This brings us to the fact that it's not simple gateway. So we are moving away from the simple data polling, so polling and response from a BMS, from a DCiM system. Here we are talking about an intelligent device, something that can bring you value. So data aggregation and then data dispatching using, for example, email or instant messaging, but also XML push, for example. So you can really use SNMP with traps for notification of alarms, but then instead of having the system polling the data continuously, you could have a recipient that is getting reports, XML reports, periodically sent by the edge itself, in a different concept of active notification. All of that, naturally, with a high level of security. So an embedded edge is creating that level of separation, and on top of that is using all the resources for this one, for this specific task. Whereas the main controller can be focused on calling continuity. There is a built-in firewall. HTTPS is enabled by default, so all the different services have to be enabled at the startup. These are very common procedures that you need to have, and there are certain standards appearing out there for data center having to do that. So intentionally, you need to enable a service that might not be encrypted like a normal protocol such as Modbus. Password strength is something we mentioned. Access log is something we mentioned that is helping security. TLS, we are currently on TLS 1.2, but we are looking at a higher level of TLS as well. And you can upload the certificates using the simple certificate enrollment protocol. So you can have them automatically downloaded for a central management of certificates and security. And this is very similar also as a concept to the lightweight directly access protocol that allows you to handle in a centralized way the accesses, the passwords, and the credentials, so that you can cancel them centrally. And this is becoming paramount, especially for larger organizations where there are a lot of different data centers. And going back to the edge, please imagine what it might be having to manage the credentials for edge micro data centers, edge data centers with a diffused footprint over the territory. Finally, together with the security, you might have secure protocols like SNMP version 3, so protocols with embedded encryption inside. Something I mentioned before, the fact it's separate, it's an edge, it's a separate device, allows you also to have redundant logic that is filtering messages from that edge in order to guarantee calling continuity on the main controller. You can destroy the edge, but still having some backup procedure to keep the unit running, even if it's not required. Maybe it's not energy saving, but it's definitely safe. And it's adding one level of redundancy and security. So in the end, this convergence between IT and OT is made there at the edge with the boss one that is connecting the devices, and it's keeping separated these two worlds, the IT with a secure network and another network between units for synergy, backup, and so on. So you keep those two red and blue lines separated, but still integrated in terms of sharing information in a secure way with the BMS system. Finally, I'm coming to the conclusions. So convergence towards the edge, using of IT technologies and IT standards is driving us probably to a different topology for data centers. And this is one example, a possible future architecture that comes from the IoT paradigm using MQTT as a protocol. So typical protocols inside data centers are SNMP, BACnet, Modbus. MQTT is appearing though, and it might be interesting what it's providing because we have an edge. The edge using this protocol is really moving the paradigms from the typical BMS connection. It's a very efficient and agnostic protocol. Small amount of data, but the ones which are necessary for a DCiM, and maybe you can have an XML push at the same time to store data somewhere else. But the good thing is that MQTT has an architecture where there is no polling by the central BMS, but the data are published to the broker by the single devices. So this is making the network also easily expandable and easily implemented because the configuration on the device is sent with a file like JSON. And as we said, it's easily expandable. So any new device will point to that broker to publish the data. The broker then is decoupling data between OT and IT and other applications using MQTT to subscribe data from that broker and using them to display, do analysis, and so forth. So we've seen that this new product, Boss One, is basically introducing the concept of embedded edge. Edge is a new paradigm that comes from the center industry, that the things are running very quickly. We believe this new paradigm coming from the IT can bring value, changing a little bit the topology of the usual current architecture of a simple DCiM, bringing local value, optimizing the data transfer, and on top of that, allowing to have a secure network and a very efficient transmission of data for a better management, a better control, and an optimization of the entire system. So if you're interested, come and visit us at our booth. Thanks for joining, thanks for attending, and see you next time if you have any question. Bye, have a good day.